Chapter 18 Review for Test. Number 1, base your answers to the following question on the diagram. So here's my voltage source, which is 240. I have 2 resistors, and it tells me the current. So first of all, the first question I'm going to ask myself is, what type of circuit is this? So this is a series circuit, and I know because the same current that's going through this resistor is going through this resistor. So for number 1, again, there's only one path for the current to flow. So it says, what is the total resistance? So in series, we add up. So RT is equal to R1 plus R2, which is 1 ohm plus 2 ohms, which is 3 ohms. So I can do that one in my head. So the answer is going to be C, which is 3 ohms. Number 2, a student needs a 4 ohm resistor to complete a circuit. Only a large quantity of 1 ohm resistors are available. Which of the following? So I want my total to be 4. Well, if I connect 4 in series, that would be R1 plus R2 plus R3 plus R4. So it would be 1 plus 1 plus 1 plus 1, which would give me 4. So the answer to number 2 is A. And I could just use the equations and look at the other ones, but here, that's our answer, so I'm not even going to bother. If they were in parallel, it would be 1 over RT, and then that would be like 1/4. Because it would be 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. All right, number 3. A 3 ohm and 10 ohm resistor are connected in series. So again, the most important thing is it series or is it parallel? So for this one, number 3, we're given that R1 is 10 ohms and we're given R2 is 20 ohms, and we know it's in series because they tell us that. They're telling us that going through the 10 ohm resistor is 2 amps. Well, in series, if I1 is 2 amps, I2 is also going to be 2 amps, because in series, the current's the same. IT is equal to I1, is equal to I2, is equal to I3, etc. The current is the same in series, so I don't even need to do a calculation there. Okay. Number 4, so the answer to number 3 is B, which is 2 amps. Number 4, when only one light bulb blows out, an entire string goes out. The lights must be connected in, well, they must be connected in series with only one path, because if one burns out, then they all would. And we talked about how they're actually connected now. All right, number 5. The circuit diagram below represents 4 resistors. So the first thing I'm going to say is a series or parallel. Well, here's my battery, and the same current is going through all the resistors. There's only one path, so I know that it's going to be a series circuit. So I know that R1 is 4 ohms, R2 is 6 ohms, R3 is 8, and I ran out of space, and R4 is 6. So if I look at the picture, this is the battery. So the voltage is 12 volts. The total resistance would be R1 plus R2 plus R3 plus R4. So RT is going to be 4 plus 6 plus 8 plus 6. So that comes out to be 24 ohms. So now I'm going to use Ohm's law. Ohm's law is V is equal to IR. So I is V over R. So 12 divided by 24, I can do in my head. So the total current is going to be 0.5 amps. And that is going to be A. Number 6, as more resistors are added in series across a battery, the potential drop across each resistor, okay, is going to be, so the answer to number 6 is decreases, okay? Because remember, if I have voltage and in series, the voltages add up. So as I add more resistors, the voltage drop across each resistor is going to decrease as I'm adding more. All right, number 7. Base your answers to the following question. So this is a parallel circuit. How do I know it's parallel? Well, when I look at the picture, here's the current coming out of the source. Part of it goes here and part of it goes here. So because the current is splitting, I know, because there's two paths here, that this is going to be parallel. So I know the question says, what's the potential difference across R2? Well, in parallel, VT is equal to V1, which is equal to V2. The voltage drop is the same. So if this is 12 volts, this is 12 volts, and this is also 12 volts. So the answer to number 8, oh, we're not calculating it. Oh, no, we're on number 7. So the answer to number 7 is 12 volts, and that's D. All right, number 8. As the number of resistors connected in parallel to a constant is increased, the potential difference. So remember that in parallel, again, this is parallel. In parallel, VT is equal to V1 is equal to V2 is equal to V3 is equal to V4. So what's going to happen? It's going to remain the same. All right. Number 9. I think there's space on this one. We don't need the paper. So again, the first thing I'm going to do is look at it and say, oh, this is parallel. I can just see, because here the current is splitting. There's more than one path. So because this is a parallel circuit, we want to find the equivalent resistance I'm going to call RT. So I know my equation is 1 over RT is 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. So 1 over RT is 1/6 plus 1/12 plus 1 over 36 plus 1 over 18. I can see that I can get a common denominator. So 1 over RT is 1 is going to be 36 would be, so 6 over 36 plus 3 over 36, 1 over 36 plus 2 over 36. So 3 and 3 is 6, that would be 12. So 1 over RT is 12 divided by 36, which I can reduce that to 1/3, but then I have to cross multiply. So RT is going to be 3 ohms. And that's my answer, which is C. Number 10, it's also parallel. So again, 1 over RT is 1 over R1 plus 1 over R2. So it's 1 plus this. So the common denominator would be 3. So 3 over 3 plus 1 over 3 is 4 over 3. So 1 over RT is equal to 4/3, but then I need to cross multiply. 3 is equal to 4 RT, so 3/4 is equal to RT. So 3/4 would be 0.75 A. And now we have questions that are just questions. Okay. So, appliances connected so they form a single pathway for charges to flow is a series circuit. So, what's the key there? Single pathway. Okay. What happens to the overall resistance of a circuit when too many appliances are connected across 120 volt? So what's going to happen is the resistance is going to be decreased. Because remember, what we're doing is, as we each add more and more appliances, that's like adding more R's. Okay. Number 13, a device that protects a circuit from current overload is called a circuit breaker. Number 14, most of the circuits in your home are parallel. Which of the following provides electrical safety? Is it a circuit breaker? Yes. Is it a fuse? Yes. Ground fault circuit interrupter? Yes. So the answer is going to be all of these. And, even if I wasn't sure, I know this and this is true, so that's why it would have to be all of them, because I can't just say A and B. And that's it.